Assalamu alaikum students. Today is my new video regarding nucleophilic substitution and elimination reactions in halogenalkanes, also known as the alkyl halides. So let's start. This is the simplest halogenalkane whose molecule contain one halogen atom which have a general formula CnH2n plus 1x, where x is the fluorine, chlorine, bromine or iodine. The halogen atom has a huge effect on the reactivity of the halogenalkanes as compared with that of the alkanes. Why? What's the reason? Because there is a greater difference of the electronegativity between the carbon and the halogen atom. So halogenoalkanes are more reactive because of their polar nature. Now the carbon bonded to the halogen carries a partial positive charge and the halogen carries a partial negative charge. Now reaction with the aqueous alkali. When we put aqueous alkali in the halogenalkane, you can see here there is a formation of ethanol and sodium bromide. So the aqueous hydroxide ion behave as a nucleophile here because it is donating a pair of electron to the carbon atom bonded to the halogen in the halogenalkane. This is why the reaction is called nucleophilic reaction. If we hydrolyze a halogenalkane with water, for this purpose we have to do a reflex action. You can see this reflex apparatus here, in which we put a halogenalkane here, a condenser here, and we heat it here. So with the help of water, the halogenalkane converted into alcohol along with the formation of the bromide ion. In water, the oxygen atom in H2O also carries a partial negative charge, whereas the hydroxide ion, the oxygen atom carries a full negative charge. From the equation above, you can see that halide ion, in this case, the bromide ion is produced in the reaction. So basically, if we put a silver nitrate solution with the halide ion, there is a formation of three different precipitates: AgCl, which is of white color; AgBr, which is of cream color; AgI, which is of yellow color. The fastest nucleophilic substitution reaction take place with the iodoalkane, the fastest one. The slowest one take place with the fluoroalkanes. Why is this? Because the iodoalkanes, the bond between the iodine and the carbon is weak with respect to the bond between carbon and fluorine. Here is the bond energy is showing the same thing which I have just told you. This is shown clearly in this ionic equation as well. This hydroxide actually replace iodine, so ethanol is formed. Now substitution of the cyanide ions in ethanol. In this reaction, basically the cyanide ion react with the bromethane. There is a formation of propanitrile. This is a very good reaction for adding a carbon atom, and we can use usually the potassium cyanide for this purpose and ethanolic potassium nitrite. If it is ethanolic potassium cyanide, there is a formation of propanitrile. You can see here this is a propanitrile. So this is a substitution with cyanide ions. Substitution with the ammonia ion. If we react the halogenalkane with the excess of ammonia molecule, there is a formation of amine. This is the amine. It could be diethylamine or triethylamine. So it depends upon it how much time we are giving for this substitution reaction. Elimination reaction. In the elimination reaction, if we use ethanolic NaOH, there is a formation of ethene. Basically, in this reaction, there is the removal of one hydrogen and one bromine, like this. There is a formation of water and sodium bromide. But if we are using aqueous solution, then there is a formation of alcohol. So it is clear this is the elimination reaction. Now these are few questions which are telling you that which are very much concerned with the nucleophilic substitution reactions. This is the first question. Which term describe the first step of the reaction? This is the first step of this is the reaction in which this halogenalkane react with the alkali to make an aldehyde. So answer is D, because this is substitution. Chlorine is removed and instead oxygen is added. This is another one. In this one, which reagent condition would result in the formation of butane-nitrile? So obviously one bromopropane heated with potassium cyanide in ethanol. Only then there is the formation of this compound, because propane, and in the propane there is an addition of carbon atom. So butane-nitrile will be formed. So answer is B. In this type of reaction, they are asking you which row describe the solvent used type of reaction. When bromethane reacts with NaOH to form ethene, it means it is an elimination reaction. So it is elimination reaction. So solvent will be ethanol. Type of reaction, elimination. So elimination is occurred, and there is a formation of ethene, as it is asked in the question. In this question, they are asking for the type of structural isomerism. So basically, 2-bromo pentane is heated with an excess of ethanolic sodium hydroxide. How many different hydrocarbons are produced? So basically, there is an elimination reaction. When there is elimination reaction, so ethene is formed. So 1 and 2 are the cis trans one, and 1 is in which there is no cis trans one. So basically, this is a combination of the isomerism and the reaction substitution nucleophilic reaction question. In this question, simple ethanolic sodium hydroxide, when it is added to the 2-bromopropane, obviously propane is formed. It is clear, we have discussed earlier. Thank you very much. Subscribe for the new videos, and hopefully you understand. For any queries, for any question, you can contact me on this number. Thank you very much.